What's up everyone, welcome to part 4 of our Pandas tutorial series, and in this one we're going to continue talking about how to manipulate our data frame by slicing, selecting columns, adding columns, removing columns, and we'll also continue plotting. So we'll continue with the CO2 emissions data set, and I found some other data sets that I'll share as well that we can play with. So let's get started. So let's continue with our CO2 emissions data set, and just to give you a recap, what this thing looked like was it was a bunch of countries, and then it was the total CO2 emissions in kilotons for each year. So this is how much CO2 Australia emitted for 1990, Austria, and then we've got a whole bunch of countries. So we've got data for each year, but what I want to do is create a bar plot that each bar represents the total amount of emissions over this entire time frame, so from 1990 to 2014. So there's a simple way we can sum up all the rows and then create a data series from that. So the way we can do that is we just call df.sum, and then the axis we're going to sum across is going to be the 0 axis. So when we run this, what we get is the sum of all the emissions over that time frame. So we've got all the way from Australia up to United States. But what you'll notice is this is not in ascending order or descending order. It's alphabetical because that's how the columns were ordered. So if we want to order this by the actual values that they emit, there's another method called sort values. And now when we do this, we get the lowest emitting all the way up to the highest emitting. So now with this is perfect for creating a bar plot. So what I'm going to do is just, I'm just going to create another data frame from it. So I'm just going to call it df totals. So now we have a new data frame that we can work with. And what I want to do is df totals dot plot. And I want to do a bar plot, and the way you can do that is just use the kind parameter, and we're just going to say bar. So now when we run this, and then we show it, you can see here that we've got all of the countries, their total emissions, all in order from lowest to highest. So now I just want to clean this up a little bit. One thing that I'd like to do is just make it a little bit wider so these aren't so scrunched up and hard to read. So you can also pass the fig size flag, and then you just give it a tuple. So we'll do 8 by 3. And what I do wrong, forgot the comma. So here you can see there's a little bit more space between the points, so you can actually read these a lot easier. We can also give it a title. So for example, we just say title, and we'll just say, we'll just do CO2, and then just to make it look fancy, we'll use the lower 2, and we'll say emissions. I think I spelled that right. Also, just to make this look fancy, let's lower this, put these in brackets, and we'll say 1990 to 2014. So now you can see we've got a nice title with some cool formatting. Drop the 2, drop this, just for style points, and that's good. So another thing I'd like to do is just add a Y label. So the way we can do that is, let's just set this equal to our axes. So we'll just say AX is equal to this, and then you can do AX dot set Y label, just like you would with a matplotlib plot, because that's what this is. So then we can just say, CO, and we'll do the same fancy thing, and we'll put this in K tons. So now you can see we've got our Y label. And the last thing that is a little bit annoying is the scientific notation thing here. It makes it a little bit weird to read. If you like it, then that's cool, but if you want to get rid of it, a simple way to do that is we'll just call ax.get y-axis, and then we're going to call get major formatter, and then set scientific to false. So now when we run this, we get actual values, like the whole numbers. So yeah, that's how you would format it. Now let's say we just want the top 5 countries that are emitting. So in order to do that, we can slice this thing pretty simply by doing the parentheses like you would a typical NumPy array. So for example, we could go back 5 and forward to the end. So here you can see we're getting the top 5 countries: Germany, Japan, Russia, EU, and United States. If we wanted the lowest 5, we could, slice this from the start up till 5. And you can see here, these are the lowest ones: Monaco, Liechtenstein, Malta, Iceland, Cyprus. Because this is a series, it's essentially a NumPy array, so you can slice it just like you would any NumPy array. So that's some basic plotting using bar plots. So now let's look at some more manipulation, how to drop rows, how to drop columns, and so on. Now let's move on to another data set where we can look at other techniques for slicing, removing, and manipulating our data frame to explore it. So this data set is a bunch of consumer complaint data. So it's like the date they complained, what company they complained to, what was their complaint, things like that. So like always, we'll do df is equal to pt.read CSV, and then this one is called consumer complaints.csv, and then let's just call df.head just so we can look at what we've got. So we've got date received. Let me zoom out a bit. So we've got date received, product, subproduct, issue, sub-issue, their consumer narrative, company response, company location, tags, a bunch of stuff. So as you can see, there's a ton of columns, but some of them we might not need. For example, we definitely don't need this complaint ID. This information is pretty useless to us. So now let's just remove this entire column just so we can shrink our data frame down a little bit. So the way we can do that is we can do df.drop, and then we're just going to specify which columns we want to drop. So I think it was complaint ID, and then we just specify the axis that we want to drop. And if you want to drop a column, you say axis equals 1. If you want to drop a row, you say axis equals 0. So when we run this, we should get a new data frame, and it should have that column removed. So if we scroll over, you can see there's no more complaint ID. So now, and I think we don't have to call the in place. So let me just double check to make sure. Okay, so in order to update our df, so that way when we call df again, we don't have that complaint ID, we can do in place is equal to true. So now, once this is done and we call df.head, you can see complaint ID is gone. So our df now doesn't have that column anymore. So now what we can do to just get some info on this data frame as far as size and things like that, we can just do df.info. So you can see all of the columns titles and then how many points they have, and it also gives the object type, or the D type. So you can see that we've got 900,000 entries and they're all objects, probably because there's so much string data that it can't create integer or float data. Cool. So now let's do a little exploring just to see, what we've got here. So what I'm going to do is let's look at the products that they're complaining about. So if we want to see what kind of products they're complaining about and how much of each one they're complaining, we can do what's called df.products. So you have to give it a series. So we want to explore one particular series. So and then we'll do value counts. And what value counts, counts df.product. And what value counts will return is all of the value counts that it finds and then the number of them. So you can see that mortgage was the most complained about product, then debt collection, credit reporting, credit card, and so on and so on. So let's say we just want the top 5. Because this is a series, we can treat it like a NumPy array. So top 5 will be colon up to the 5th one. So here you can see we have top 5 complaints or product complaints. So with that being said, let's do a little bit more exploring. So if we go here, let's look at the student loan complaint. So let's say we want to take our data frame and we just want the entries where the student loan is the complaint. So the product is the student loan. So the way we can do that is we can filter it by using, well, I think what it's referred to as like a truth table. So if we were to do something like df.product, and then we set that equal to student loan, you can see that this is just going to return a series that's it's either true or false. So if this series, if like in the product column, if it's not student loan, it'll return false. And when it is, it'll return true. So we can use this to filter our data frame. So the way that works is we'll just put this in brackets and we'll just say, I want to take my data frame and I just want when the product is equal to student loan. So now when we run this, we're going to get a data frame and you can see that the product is always going to be student loan. So now we have this subset of the data set where we're just looking at the student loans. So that's one way to filter is you can use this equals way. If you're dealing with numeric data, you can say I just want values greater than or less than some value to filter it. But because we're working with strings, we'll use this way. Now that we have this data, let's look at maybe try and figure out some more information about this. So now we have the product and let's see which company was the most complained about. So if I go to company, let's just take the company column, and then what I want to do is let's look at the value counts. So now we can see the top companies that people are complaining about with their student loans. So we've got Navient Solution. They're by far the most complained about company with student loans. Then some other one, AES, and yeah, but they're not nearly as big as this Navient. So, just by a little bit of exploring, we can see which company is kind of the most complained about as far as student loans. And we can do the same thing for other products. Like if we wanted to do mortgage, you saw that one was a very complained about product. So you can see Bank of America is the most complained about, then Wells Fargo. So we've got all the big banks are, people are complaining about their mortgages with these companies. So yeah, if we wanted the top 5, you can see here that we get the top 5 complaints. And then if we wanted to say create a bar plot, we can just call kind.bar, plt.show. And you can see we've got a nice bar plot of all the complaints for mortgage. So let me just, get that out of the way so you can see it better. So yeah, here's a quick way of creating the bar plot, and then we can tag it with a title and a Y label and so on and so on. So that's a quick way of filtering our data and getting some info from it. So the key ones are info, which is nice, value counts, and then we can also slice it to get the top 5 or bottom 5 out of that. Cool. Now let's look at some time series data, and the classic time series data that people look at with Pandas is of course stock prices. So I've grabbed a data set of stock prices from Kaggle. I'll add a link in the description, but again, we'll create our DF, and that's going to be pt.read CSV, and then the file name is called allstocks5year.csv, and let's just do df.head just so we can look at it. So you can see that we've got the date, the open, high, low, close, the volume, and then the stock name. And if we were to plot more of it, you can see that we've got the name, but then there's a bunch of other names in there too. So each chunk is like a different data set. So it might be good to say, break this up into a bunch of smaller data frames. Let's say we just want the Apple data set. Well, what we can do is, like before, we can do df dot name, and then we're gonna slice it, and then we're gonna take just when the name is equal to Apple, which I think is AAP. So now when we run that, we're just gonna get the data for the Apple stock price. And you could do this with any of them. Let's say we want to know all the stocks that we have available. Well, one trick you can use is an object type called the set. So what a set does is you feed it a list, and if you have repeated values, there will only be one entry. So it'll only be unique values in a set. So the way we can do that is, let's say we'll just create a set, and we just want df.name. So now you'll see we'll get a list, or actually the type is a set, and we'll just get all the options we have all the way from, A to ZTS. So if we wanted, if we just wanted to make this a list, so we'll just call it stocks, and we'll just say list. So now if we want to refer to this later, we can. But with that being said, let's look at the Apple data. So let's just call it df AAP. And remember, that's going to be when we filter it by name, and the name is just going to be the Apple one. So now if we want to plot this thing, well, first thing, let's parse the dates. So that's one thing we forgot to do. So you could see before, if we called df.head, really the date is the column that we want to parse the dates with. So let's just go back in and reset this up, and we'll say index call is equal to date, and then let's just do parse dates is equal to the date. So now when we call df.head, we've got our index as date. So this will make it nicer when we plot this thing. So let's go ahead and get our Apple data. So df.name is equal to AAP. And then if we wanted to plot this thing, let's rename it so we don't have to call it again. But then if we want to plot this, again, we can just do df AAP dot plot and plt dot show. Cool. Let me just run this again. All right. So you can see we get all 5 of them. We get open, high, low, close, and volume. But you can see the close is probably, let's just go for like the open and the high. So again, if we just want to select a subset of them, what we can do is pass a list of the columns we want. So let's say we want open, and let's also do high. Cool. So now you can see we've got 2 time series signals, the open and high prices. And then because we've got our dates parsed, we get a nice date axis for the x-axis. Cool. So again, let's just make this a little bit wider. So we'll go with 8 by 8x3 just to make this thing bigger. And yeah, 8x4 just so we can see this a little better. Cool, so this is how we would work with time series data, plotting time series data. And yeah, with that being said, I think we'll call this video a close. And then in the next one, we're going to look at how to filter, how to do a rolling filter, and then also some other filter techniques to smooth these lines out a bit. So yeah, stay tuned for the next one. If you liked the video, leave it a like. If you got any comments, leave a comment below, or you can use the Facebook group to chat more. And if you're interested in seeing more videos, then hit the subscribe button. Thanks guys, see ya.